Lesson 10.8, Equations of Circles. Bonus notes. We're going to continue with what you saw in the last recording and talk about how you can write an equation in the form for the equation of a circle if it's in standard form or general form instead of standard form. Let's take a look. All right, I apologize for this last bit of notes not being on the previous recording, but let's pick up where we left off in lesson 10.8. This is about halfway down the last page of the notes for the chapter, and we run into an example here where we're asked to state the coordinates of the center and the measure of the radius for this equation, where it's not written in standard form yet. It's written in what's called general form, and we have to make this look like this. And to do that, we're going to call on some Algebra 1 skills, and that is what this is for up here. We need to remind you of how to do something called completing the square. This is going to be some pretty fancy dancing, so stick with me. Let me move the notes for just a moment. Now, in standard form, the equation of a circle has a couple of binomials that are squared, like you see here. X plus 6 is a binomial, and when that whole thing is squared, I could multiply it all out and end up with what's called a perfect square trinomial. Now, I can create a perfect square trinomial if I have an x squared and an x term by looking at the coefficient of x, taking half of that and squaring it. So half of 12 is 6, and 6 squared is 36. We'll come back to this in just a moment in slower detail. But if I can create a trinomial that's a perfect square trinomial, then I can factor it back into a binomial squared. So that's what I'm going to have to be able to do. So let's remember how to do this a couple of times. And if you already know how to complete the square, you can just go ahead and fast forward on to how to tackle the problem at hand. At the top of the notes that I'm continuing on here, completing the square is the process of changing a binomial like this one into a perfect square trinomial so that it can be factored into a binomial squared, like the things that we'll need in standard form for the equation of a circle. To complete the square, if I have an x squared term and an x term, I just need to add on one more term. And that one more term that I'm adding on is half of whatever b is squared. So let's do it a couple of times just so we can see how that's done, and then we'll use it. So here I have a binomial. The leading coefficient is 1. And if I want to create a perfect square trinomial, I'm going to take the number in front of x, split it in half, and square it. So in this case, that's going to wind up being 4. That's the value of b. Divided by 2 squared. So 2 squared. That's the number I need to add on to this in order to have a perfect square trinomial. And to remind you, a perfect square trinomial can factor into a binomial squared. Two numbers that multiply together to give me 4 and add together to give me 4 are 2 and 2. X plus 2 times x plus 2 can be expressed as x plus 2 squared. So by taking half of 4 and squaring it and making a perfect square trinomial, I can create a binomial squared, like what we'll need in the, our standard form down here. Let's do it one more time. I'll do it in a different color. So one more time, I have a squared term and just the variable term there. In this case, the value of b is -8. I'm going to take half of b and square it. So half of -8 is -4, and -4 times -4 is positive 16. Because I'm squaring it, that number that I'm adding on is always going to be positive. So to complete the square, there it is. And the two numbers that multiply together to give me 4 and add together to give me -8 are -4 and oops, that's a y, -4 and -4. If I multiplied this out, I'd have this perfect square trinomial, And because it's the same thing multiplied by itself, I can express it as a binomial squared. Okay, so now that we know how to make, how to complete the square, so that we have a binomial squared, let's go ahead and apply that to this last problem. You'll have one of these in the practice assignment tonight. So the standard form of the equation of a circle has binomials squared, and those are the things that help us to identify the center of the circle. In this formula, the circle's center is the value of h for the x value and the value of k for the y value of that center. So we can use our knowledge of completing the square to put an equation in standard form and easily identify that circle's center. So this is not in standard form, but we can put it there. Let's watch how we can do this. So I have x squared plus y squared minus 8x plus 2y equals negative 8. Ugh. Well, I'm going to pull together all the things that have x in them, and I'm going to pull together all the things that have y in them, and I'm going to create a binomial squared. So I'll keep the color coding going here. I have x squared minus 8x. Now I'm going to complete that square in just a moment, so I'm going to leave a little bit of space here. And I have y squared plus 2y. And again, I'm going to complete this square, so I'm going to leave a little space. And that's going to be equal to negative 8. All right, let's go ahead and do this, keeping in mind that this is an equation. Let's complete the square here. I'm going to take half of negative 8 and square it. Negative 4 squared is positive 16. Now, let's remember that I'm not just completing the square. I'm in the middle of an equation here. And I just added 16 to the left side of this equation. So I better add 16 to the right side of this equation so that I keep the equation balanced. Let me go ahead and change this from a perfect square trinomial to a binomial squared. Negative 4 times negative 4 would be positive 16, and negative 4 plus negative 4 would be negative 8. All right, so now I know the x value of the center of my circle. Let's go through this same process to find the y value for the center of my circle. All right, one more time. I'm just going to do it on this paper here. I'm going to take half of b and square it. This is the b value. 2 divided by 2 is 1 squared, and 1 squared is just 1. So I'm just going to be adding on 1 to complete the square. So here's y squared plus 2y, and I'm adding on 1 to complete the square. Now, just like I did before, I added 1 to the left side of the equation, so I better add it to the right side of the equation as well. And now I can write this as a binomial squared. Sorry, there was just a little interruption there. Two numbers that multiply together to give me 1 and add together to give me 2. 1 and 1, so that's y plus 1 squared. All right, when I added the 1 to the left side of the equation, I added it to the right side. When I added 16 to the left side, I added it to the right side. Over on this side, I started with negative 8, and I added on another 17. So it looks like that's going to put me at 9. So now we have this in standard form. I can easily see that the circle's center is positive 4, negative 1. And this is the radius squared. So the radius is going to be the square root of that. Now this is easy enough to graph. Let me scooch up a bit. The center is 4, 1. The radius is 3, so I'm going to move out 3 units in these 4 directions and then just sketch it in. I think I went too far. 1, 2, right there, not that one. And not bad. Not perfect, but not bad. So there's my circle with a radius of 3. Not going to use this all the time, but this is a nice refresher of completing the square. And this is how we can use it to write the equation of a circle.